Okay guys, so now we're going to start talking about explicit definitions of sequences, and hopefully you'll find that these are a little bit more useful than recursive definitions. So the sequence A of n is defined explicitly here to be 3 plus 2n. And then we're asked to give the first three terms of the sequence. When we were using recursive definitions, this would have taken us some time, but here you'll notice this is just one statement. Recursive definitions had two statements. They told us the first term, and then they told us how to find any term after that term using the previous term. But this type of definition allows us just to find the term we want by plugging in the number we want for n. So for example, if I want to find the first term, that's a of 1, right? Well, all I need to do here is plug in a 1 for n, and that'll give me 5. So it looks like the first term is 5. If I want the second term, I just have to do 3 plus 2 times 2. And 2 times 2 is 4, plus 3 is 7. So 7 is my second term. If I want to find my third term, that's going to be 3 plus 2 times 3, which is 6 plus 3. That's 9. So these are the first three terms. That's the first term, that's the second term, and that's the third term. If we had done this recursively, we would have had to write this from this list of terms as, okay, our first term is 5, and then what's the pattern here? Well, it looks like it's plus 2 from one term to the next. So to find the nth term, I'll just take the previous term and add 2. And that would be a recursive definition. Hopefully you'll start to see that these definitions, explicit definitions, are more useful, especially if we want to go way down the line and find the 20th or the 1000th term of any sequence. Okay, so let's do some examples. I'm asking to give the first three terms of each of these sequences. So the first term is b sub n, and the first term of this sequence is going to be b sub 1, and all I have to do is plug in a 1 for n. So 0. And I'd encourage you to just pause this video and finish the rest of these if you can and check to see if you did them correctly. But our second term is going to be 2 minus 1, and our third term is going to be 3 minus 1. So those are the first three terms of our b sub n sequence. You'll notice that because the pattern that's taking place is just minus 1, minus 1, minus 1, minus 1 every time, this would be classified as arithmetic. And we do still want to think in terms of classifying these sequences if we can. We won't be able to classify all of them, but any one that is arithmetic or geometric we should recognize. Okay, c of 1, to find the first term in our c of n sequence, is going to be 3 times negative 2 to the first power. Negative 2 to the first power is negative 2, which times 3 is negative 6. So I want to find the second term. That's going to be 3 times negative 2 squared. Negative 2 squared is going to be 4, right? Negative 2 times itself is going to be a positive 4, and 4 times 3 would be 12. And then the third term rather, is going to be 3 times negative 2 to the third. Negative 2 times negative 2 times negative 2 is going to be negative 8, and negative 8 times 3 is negative 24. So those are the first three terms, and you should notice that the pattern between each of these is that it's multiplication by negative 2 every time. So this would be a geometric sequence. Now the last one. Our first term of this d sub n sequence would be 1 divided by 2 plus 1. Alright, so 1/2 plus 1 would be 3/2 if I find a common denominator and then add those together. Okay, the second term is going to be 2 divided by 2 plus 2. Okay, so 2 divided by 2 is 1, and 1 plus 2 is 3. And then lastly, the third term is going to be 3/2 plus 3. And I'll make a common denominator here. So this is the same as 3 halves plus 6 halves, and that's 9 halves. Now you'll notice that in this sequence, there's division happening and there's addition happening. There's a lot going on. So this is not strictly recursive or geometric. We cannot classify this sequence right now. So what I'd ask you to do, and I'll just post the answers here very quickly in a minute, is find the 15th term of each sequence above and think about what would go into this if these definitions were recursive and not explicit. So for each of these sequences, find the 15th term, and then you should pause the video here so that you can look at the solution in a second. All right, so these are the solutions, the 15th term of each of the above sequences. Hopefully you did those correctly, and tomorrow we are going to do some practice revolving around using these explicit definitions.